The YouTube link has been shared in the chat box. If any of your friends wants to join and view it, you can share it to them. Kalichelvi ma'am, are you there? Kalichelvi ma'am? I'll just call her if there is any problem in joining. Okay. One of you just check whether ma'am has joined.
No, she has not joined, Lavanya.
Thank you. Oh, maximum message. Oh,
If you make them free.
For her also it says maximum has reached.
Yeah, it's better. Make them to somebody to go out.
Yeah. Some of our students, you please leave and join the YouTube. The feedback link will be posted there also. So our students, MSc and MCA students, please join our YouTube link and please leave way for the resource person.
To the UGC. That is 2 to 3 members can go to the YouTube link.
Yes. Our research scholars, other research scholars also please can cooperate. Ma'am is joining in the name of Priyadarshini.
Give a call to her.
No, actually she is trying.
Dr. Lavanya.
Yes, ma'am. Yes, ma'am. No, she's messaging. Yeah, she's joining. Actually, she tried. It seems 100 participants. Now the students and scholars have cooperated. So, yeah. Yeah. Check like her name. She's joining in the name of Priyadarshini. Yeah, ma'am joined. Kalichelvi, ma'am.
Okay, yes, good afternoon.
Yeah, good afternoon, good afternoon.
My daughter is using my laptop, okay, for online classes. So I think the name is changed.
Okay, that's again a very good name, ma'am, Priyadarshini. Shall we start?
Yeah.
So we shall start, ma'am. Start recording and start.
There are no secrets to success. It is the result of hard work, preparation, and learning from failure. A warm good afternoon to one and all present here. I welcome you all on behalf of UGC HRDC and Department of Computer Science, University of Madras for National Webinar on Data Analytics. The webinar is composed of 2 sessions on topics Machine Learning in Data Analytics and Applications of Data Analytics. I request you all to attend both the sessions and use this great opportunity. Let us start our session with Tamil Thai வாழ்த்து.
நீராறும் கடலுடுத்த நிலமடந்தை கெழிலொழுகும் சீராறும் மதனமென திகழ்வரத கண்டமிதில் எக்கணமும் அதில் சிறந்த திராவிடனல் திருநாடும் தக்க சிறு திரை நுதலும் தரித்தனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிழமை திறம் வியந்து செயல் மறந்து வாழ்த்துதுமே வாழ்த்துதுமே வாழ்த்துதுமே.
Success is the sum of small efforts. I request Dr. B. Lavanya ma'am, Associate Professor, Department of Computer Science, to welcome the gathering and the resource person.
Yeah, participants, please mute yourself. Good afternoon to all. It's indeed my pleasure to good afternoon all. It is indeed my pleasure to welcome all for UGC HRDC University of Madras sponsored National Webinar on Data Analytics organized by Department of Computer Science, University of Madras. I'm happy to welcome our Honorable Vice Chancellor Professor S. Gauri and Registrar in Charge Professor Dr. N. Madhivanan for this program. I welcome Professor V.P. Madheshwaran, Director, UGC HRDC, University of Madras. I welcome Dr. N. Kodandraman, the Deputy Director, UGC HRDC, University of Madras, and thank him for his initialization and motivation for the conduct of this national seminar. I delightfully welcome our resource person, Dr. T. Kalichelvi ma'am, Assistant Professor, Department of Computer Science and Applications, the Gandhigram Rural Institute, and Dr. D. Mini, Associate Professor and Head, Department of Computer Science, Madras Christian College, Chennai. Also, as a coordinator of this webinar, I welcome Professor Dr. P. Thangavel, Head, Department of Computer Science, my colleagues, Professor Dr. P. L. Chitra, Professor Dr. M. Sornam, and Professor Dr. S. Gopinathan for this webinar. I welcome all participants, students, and research scholars pan-India and thank them for their continuous support in all the academic activities of Department of Computer Science, University of Madras. I hope this webinar chaired by our eminent persons throw light on the different aspects of data analytics. Welcome all. Now I take the privilege of introducing our session 1 resource person, Dr. T. Kalichelvi. Dr. T. Kalichelvi works as an assistant professor at the Department of Computer Science and Applications in Gandhigram Rural Institute. She has completed her MCA, PhD, PDF. She has 13 years of teaching experience. Her research area includes medical image analysis. She has more than 15 publications in national and international journals and 21 chapters in national and international proceedings and edited volumes. She has published a book. She is a principal investigator for many number of projects and currently for DST sponsored project titled Development of an Automatic Tool for Brain Image Extraction and Brain Tumor Detection for MRI scans, worth 8.7 lakhs. She has visited Malaysia, Canada for various conferences. She has guided 13 MPhil scholars and currently guiding 4 MPhil scholars and 5 PhD scholars. Ma'am, we are waiting to listen to you. The floor is yours.
Thank you. Thank you, Dr. Lavanya. Am I audible?
Yes, ma'am.
Okay. Thank you. So first of all, I'd like to thank the UGC HRDC and the organizer of this program. I have seen Dr. Chitra madam also on the screen. Good afternoon, madam. Okay, and other Dr. Thangavel sir, Dr. Swarna madam, Dr. Gopinathan sir. I am familiar with everyone because I have attended my refresher course there in the Gandhigram during 2012, I think. Okay. Thank you so much.
Welcome, madam. Welcome, welcome.
Thank you. Thank you. Okay.
Mm.
So there are so many participants are here. Actually, this is a good approach for propagating the latest technology with the scholars and students. I think, shall I start my topic?
Yes, ma'am.
Okay, thank you. I'll share my screen. Is it visible? Screen?
Yes, ma'am. Yes.
Okay. So good afternoon, everyone. Here, I'm here to present this title. Okay, my lecture is based on this title, Machine Learning in Data Analytics. Okay, this presentation is in your national webinar today. So before start this my topic, I'm happy to share about my experience with this concepts. And past 15 years, starting from 2006, I have started my PhD under the Young Scientist Scheme DST. 2006 onwards, we are working in this medical image analysis. So we are very much familiar with this image data analysis. And step by step, we have developed our techniques, models, methods, starting from normal programming to then machine learning programs, switch to machine learning. Then again, now we are working with the deep learning concepts. So that's what here today. First, I will discuss some of the concepts. Okay, like what is a data and what is data analytics? Because here so many students are here, and a new joined PhD scholars or PhD scholars, those who are searching for research areas. Okay, those people are here. So I'll start with this data analytics. Then I'll go with this kind of machine learning. What are the concept of machine learning used with this data analytics and how can we use it? And I will explain with some kind of examples to you. Okay. Here. Okay. So here first data. Okay. As soon as you hear this word, okay. Nowadays, everything is, we're referring it as a data, COVID data, RT-PCR sheets. Okay, so everything's data is everywhere in sheet or in social media platform. We can have so many, where we are passing so many videos or so many speeches or audios, podcasts. Okay, so many things. Okay, or in some kind of, while we are going for online shopping, then product reviews or some kind of feedbacks. Immediately before we are going to place any order, we will immediately go for this feedbacks, okay, or reviews. We will go through it, then only we'll go for the orders. Okay, so that's what this data is everywhere. Okay, so that's what data is nowadays. It's a new oil of the digital economy. Okay, I like this sentence, so I have placed this in my screen. Okay, so based on this, now we can say what is data. If I ask what is data, you can say that data is an information. Okay, some may say that data is an information, and some may they say that data is nothing else, but it is a kind of graph. Mostly in TV channels and all, in news channel, they will use some kind of graphs to explain something. Okay, or the data may be a measurement. Okay, this data may be a measurement. Okay. it may be a information, or it may be a graph, or it may be some measurement like height of building. Okay, like some measurement can be used, or some kind of observation. Okay, or suppose a question, a query like how many people, okay, and how many people averagely affected by this COVID in this area. Okay, so some kind of observation or some kind of fact, or data may be with some kind of number. Okay, number, that is number of children, or number of ladies working in this area. Okay, like some number of some numbers or some quantity. Okay, so these are different forms of data we are using in and around our environment. Okay, so that's what in data. Okay, theoretically this can be divided into two ways. One is a quantitative, another one is a qualitative data. Okay, quantitative data, qualitative data. So the quantitative data is mostly the numbers. Okay, the numerical data is known to be the quantitative data, whereas this qualitative is a kind of descriptive, Okay, the core is in the red color. Okay, the tissue are very soft. Okay, it is a kind of qualitative data. So in a quantitative, whether there are numbers can be defined in a discrete form of way or in a continuous way. So here the discrete is usually discrete. You all understand that they are usually counted forms. Okay, so the number of children in a particular house, there are 2 children in a particular house, or there are 250 students in this department. They are the discrete form. Or this continuous is usually it is a measured form. Okay, like a building height. Okay, or some weight of something. This is the continuous form. Okay, so this is the base classification about data while we are using theoretically. Okay, so in this, so as I already told that data is everywhere. Okay, so data is everywhere. Usually what we will do in our daily life or in our business, if you want to equip with our some your education qualification, initially what you will do, you will start to analyze that what will be the next best degree we can do, whether I can do the degree in online or in offline, or I can join in a nearby institute, or I can join in online course in a foreign institute. The kind of analysis we can do. Okay, because that much of data is available with you, so you can collect all those details and you start your analysis. Okay, so that's what here with this data, this analysis, by combining these two things, this is the data analysis is nowadays a very popular terminology used with our computer science. Okay, so this data analytics, okay, based on that, the data analytics refers that here this is data analytics is nothing else, but already I told that now data is in quantitative and qualitative. Okay, so you can approach the analytics, you can make this analytics either in quantitative way or in a qualitative way. Okay, so this is the set of quantitative and qualitative, or both you can do. Okay, so the data set of quantitative and qualitative approaches for driving valuable insights from data. Okay, so here your aim is you try to find out which course will be more suitable for your ambition. Okay, so you maybe want to become a big researcher, or you maybe want to become a big academician. Okay, or you maybe want to become a big businessman. Okay, so based on that, you can analyze the available data, then you can find out, find out a valuable insight from the data. Okay, so for this thing, it will involve many processes. Okay, so the using set of quantitative and qualitative approaches, these approaches are used for extracting data and categorizing it. Okay, we will use these approaches for extracting the data and categorizing them. Then after that, for deriving variable insight, okay, what are the variable insight? They are nothing else but the kind of patterns, what kind of patterns you want to drive, or what kind of relations you want to drive, or connection, or other such valuable insights from it. Okay, so this is the concept of the data analytics. Okay, now we have to know, understand this data analytics. Okay, so this word is using, okay, we are using this word now. So this is used, actually this is fitted with which area. Okay, so here in this diagram, here this data analytic is, okay, the data analytic model, or we can say them as artificial intelligence model or robotics model. Okay, so the data analytics, the other forms are the related with this are artificial intelligence and robotics, as well as this data analytics and AI and robotics, they are coming from, they are the part of data science. Okay, they are the sub area of the data science. This data sciences is actually a multidisciplinary area but its major portion is in computer science only. Okay, comes under the computer science. Okay, so again in this data analytics or artificial intelligence and robotics, there are so many techniques and algorithms and methods are available. In that, one of the nowadays very popular algorithms are machine learning algorithms. Okay, machine learning algorithms. Then the machine learning algorithm again having one more subdomain, that is the artificial neural network. There the very popular terminology is deep learning. Okay, so this you have to understand. Okay, so for doing this data analytics or for developing any artificial intelligence technique or for developing any robotics model, okay, so we can develop our methods and algorithms using this machine learning or artificial neural network models or deep learning models. Okay, so in this, here the data analytics, okay, for doing this analytics, we can either use this AI model. There are so many AI techniques are available. Okay, you can make use it, or you can make use the machine learning or deep learning. So the kind of analytics, what kind of analytics you can do is, here I already told that data is everywhere. Okay, you can have a plenty of data in your hand. Okay, so there the kind of what kind of analytics we can do is, we can, that is the very popular thing is data cleaning. Okay, it's a kind of pre-processing. Okay, data cleaning you can do, or data transformation. So the data transformation means here you can convert your data from one domain to another domain. That may be convenient to you. Okay, some may be work with a spatial domain, some data may be better to visualize in the frequency domain. So that time you have to transform the data from one domain to another domain. So this is an example. Okay, so this kind of analytics you can do, or data exploration you can do, or some kind of hypothesis testing, like kind of analytics we can do, or nowadays it's a very popular terminology is data visualization. Okay, data visualization also we can do. Okay, so for doing all this kind of analytics, either you can develop some kind of AI models or machine learning models or deep learning models, but they are interlinked only. I will explain. Okay, am I audible?
Yes, madam. Continue.
So in this, this is the data analytic process pipeline. Okay, there are 6 steps. Okay, there are the 6 sequence steps in this. The first one is data preparation. Okay, so in this data preparation, based on your domain or based on your application, here you have to do this data design or experiment or formulating the problem. Everything you have to do. This is the first analysis part, like our system development. First you'll do the analysis part, no, system analysis. Likewise, here you have to do this data preparation. Then after that, in the second step, here you have to start to do your analytics part. Okay, data analytics. You have to explore your data by using some analytic function. Then that is followed by, okay, but nowadays data visualization. Okay, once you're doing during that time, you can do this data visualization. So these 2 steps are interlinked. Okay, these 2 steps are known as the data analytics portion. Okay, then after that, immediately once you're well with this data analytic portion, then naturally you will go to try to extract the patterns you like. Okay, the insights. Okay, the insights you have to try to extract. There you have to involve this machine learning algorithm for classification or grouping, clustering. Okay, for classify some patterns or grouping some patterns. Okay, after doing this classification or grouping, clustering, then you will that algorithm will support you to predict something. That is known to be the predictive analysis. Finally, once everything is defined, then they will done perfectly, then a kind of AI model will be produced. Okay, that is the ultimate final outcome of our data analytic process. Okay, so in this, the major 2 portions, the first one is data preparation, last one is the final model. Okay, that is the input, that will be the final output. In between, okay, in between, the major process are, one is the data analytic process, another one is the machine learning algorithms. Okay, these 2 you have to be worked with these 2 concepts. Okay, so in this, first we are going to discuss about the concepts or the base with this data analytics. Okay, the steps in data analytics are only with this data analytics. The steps are again 5 steps. You will get the data, then you start to analyze the data, then visualize it, publish it, consume it. These are the simple step. Okay. So here I will explain this data analytic portion with a simple example. It's already the example. Okay. So in this, it's just this example is familiar to every one of you because we are working with the image data. Okay. And later I will explain. While I explain the machine learning algorithm, I will explain my concept of our research area to you. Here a simple textual data is taken. The census data is familiar to all of you. Okay. So usually in census data, we will note down all this house number starting from the house detail, then husband age, wife age, husband income, wife income. Okay. Number of bedrooms in the house, electricity units, gas, number of children. Then nowadays, since we are living in a digital world, internet connection, mode of connection, house owned or rented, speaking language, up then the house age, okay, decade of house built. So these are some of the details we have collected for under this census data. Okay. So naturally, these details will be placed into a Excel sheet. Okay. The census data sheet. This is known to be the census data sheet. So this is an Excel sheet or a CSV file. Okay. So here I already told you, once you design a data, then you will have to define the problem statement. Okay. So here using this data, once a data is prepared, here your problem statement is, okay, your problem statement is, so using this data, okay, using this data, the census board wants to know the minimum and maximum and average age of wife. Okay, minimum age, maximum age, and average age. These are some just an example. And second, the second problem may be the statement is know the median, quantile, variance, standard deviation of the husband income. Okay, so here mostly these are related with the, okay, these are related with the simple statistical analysis. Okay, then and the last one is find the frequency of the number of children and number of bedroom. Okay, so these are the problem statements. So for doing this, okay, for calculating, for deriving this, naturally what we will do in our, okay, everything is in that Excel sheet now. So we will import the data set. Then we'll perform some data cleaning. Okay, data cleaning means here in our previous screen, we are having a Excel sheet. Okay, in that Excel sheet, there may be, sometimes there may be missing data may be there for some rows. Okay, in row wise, we are having the details of each house. Okay, in some rows, the data may be missed. Okay, there you have to fill it. Okay, but here, because you going to use this formulas, statistical formulas, finding the minimum, maximum, average, then they will expect a number in each and every call a cell. Okay, so that's what this is, one kind of missing data you have to identify, or sometimes unrelated data may be entered in that. Suppose in number of children field, there may be 2, 3, 5, 6. Okay, sometimes 100, 200 value may be entered wrongly by the data entry operator. Okay, so that is a very unrelated data that you have to rectify. Okay, so this kind of data cleaning you have to, once you import your data set, you have to do this data cleaning. Okay, once you are satisfied with your data set, after doing all this data cleaning concepts, okay, since it is a textual data, we can do this kind of pre-processing. For image and all, there are so many pre-processing techniques are available. In images, what we say it as, they are the noises, okay, image noises. So we have to remove the noises sometime, okay, or sometimes the contrast may be very low in the image. They may be very blurred concept regions there in the images. That time we have to improve the contrast. We have to enhance the images also. Okay, this kind of data pre-processing required while we are working with the images, but here it is simply a textual data. Okay, then after that, based on the problem statement, here we already are given the problem statement. No, based on that statement, for the first statement, okay, first statement, you have to calculate the minimum, maximum, mean for the wife age. Then for the second statement, again, some kind of statistical calculation, median value, quantile value, variance, standard deviation. And last one is, for the last one, you have to find the frequency of, okay, frequency of number of children means naturally you will plot the data for the number of children and number of bedrooms. Some graph may be plotted for this. Okay, so this kind of, okay, this kind of analytics we are doing. Okay, so in this some analytics, okay, some analytics we are finding the value. Okay, some analytics we are drawing the graph. This graph maybe support the census board or government to take some decision for the future or to take some decision regarding some particular area. Okay, so that's what this data analytics, while doing this data analytics, they are categorized into 4 types. One is the descriptive analytics, another one is the predictive analysis. Okay, predictive analysis. This plot, a chart drawn for this number of children, that may be useful for the government to take any measures regarding this educational technology for the education related with education technology for the particular area. Okay, so that kind of predictive analysis may be done, or diagnostic analysis may be done, and prescriptive analysis. Okay, so in this types of data analytics, the first one is descriptive analysis. Okay, the descriptive analysis is very simple. You work with the incoming data, then you will do some analysis and that, and finally you will give some description based outputs. Okay, so that is the descriptive analysis. Whereas in predictive analysis, here you will using the given data. Okay, now in your hand you are having the data. Using the data, you will predict it for the future course of action. Okay, you will predict something. Okay, the data is like this. So in this area, the number of children are like this many number of children are available in this age group. So likewise, you can predict something. Based on that, the action may be taken. Okay, predictive analysis. Diagnostic analysis means here they will take both the present and past history also they will consider. Okay, looking into the past and determine why certain thing is happened with this. Okay, that is the diagnostic type of analysis. Okay, this is depends on the application domain in which you are going to work. And prescriptive analytics. Prescriptive analytics is maximum the analysis based on some rules and recommendations. Okay, then based on that you will derive the future plan for that. Okay, for any organization and anything. Okay, so that is the prescriptive analytics. Okay, so once if you're going to work with any kind of data, then in your problem statement, first you have to sure about in what kind of analytics you are going to derive with this given data. Okay, and for doing this, the tools for data analytics, there are a lot of tools are available for doing the data analytics. I think every one of are familiar with this Python. Okay, and Hadoop also, Hadoop and R. Okay, and seeing this, there are so many tools are there: SAS, Tableau, Python, Hadoop, Spark, Slick, SQL Server, R. Okay, so many tools. These are popular are Python, R, and Hadoop. Big data analytics, we can go with the Hadoop, or some kind of RDBMS based some analytics. You have to some query based analysis you want to do, then you can go with this SQL. Okay, likewise, there are so many tools are available. Then in this first Spark is a framework. Okay, it is a real-time data analytics. It is a Hadoop ecosystem. Spark is Python is a kind of programming language. Almost every one of you nowadays working with this Python for developing our machine learning algorithms. Okay, Python is best for developing a machine learning based applications. Okay, and TOS is one more analytical tool. Okay, this is used for work with big data analysis, only huge volume of data. Okay, then Hadoop is popular big data framework. And SQL, I already told you, work with the RDBMS systems. And Tableau is one kind of business intelligence tool. Okay, if you have any plan with work with any business level based any analytics, financial analysis, then you can very well go and work with this Tableau instead of this Python concept. Okay, then Splunk is again one kind of tool related with the business analytics. And R programming, yes, it is a best for one of the best tool for data scientists for the purpose of statistical computing and graphical applications. Okay, then this data analytics, this kind of analytics, there are so many applications are there. They are categorized into data analytics in finance, data analytics in healthcare, data analytics in marketing, data analytics in human resource HR, data analytics in IoT, data analytics for business. So mostly this finance, marketing, HR, IoT, business are related with the finance related applications. Okay, so in this, the one different one which I choose is to discuss about this data analytics in healthcare, because we are working with medical image analysis. Okay, so now we will see what kind of analytics will be supportive in this healthcare environment, because you all know that nowadays, wherever you visit in a hospital or simple click anywhere, your data immediately they will feed your data into a computer system only, because everything is streamlined. Okay, the patient entry is streamlined everywhere. Okay, so this will help to improve the patient care. Okay, so here once if you keep on visited the same hospital, they will immediately take your past history. Okay, and they will compare your current problem with your past history, or sometime they can try to find out the similar history that is based on your symptom. They will compare and try to extract the records of the similar history, and they will check it out. Okay, so these kind of concepts are possible with this in healthcare. Okay, so that's what here. This in case suppose a patient is required for hospitalization, then this history, past history, and history of other patient data, okay, these are help to predict the kind of what is the infection risk and deterioration or readmission is required. Okay, so this analysis helps to lowering the expenses, and same time it will help to improve the patient care outcomes. Okay, these are the two main objectives of using this data analytics in healthcare nowadays. Okay, then in our data analytic process, next is, okay, so a kind of data analytics after completing this, and next is we have to concentrate this machine learning algorithm. Okay, so in this machine learning algorithm, okay, the machine learning algorithm, again there are so many applications are there, starting from image recognition, speech recognition, medical diagnosis, statistical arbitrage, predictive analysis, and extraction. Okay, these are the popular real-time examples in where we are using this machine learning algorithms. Okay, so in this, the first one and third one, image recognition. Okay, it is one of the well-known widespread example of machine learning, because you all are familiar with this face recognition. Okay, so here the image is nothing else but here it is a digital image. The image is represented as the intensity of the pixel. Okay, the intensity may be a black and white, or it may be a color image. Okay, so in the real world here, this image recognition is used to, okay, in a X-ray. Okay, in a X-ray, as soon as that algorithm, if you are given this input, a X-ray input to the machine learning algorithm, then that model has to identify whether any cancerous cells are available in the X-ray or not. Okay, this is one example related with the medical field. Otherwise, if you give a photograph, okay, mostly these applications are used with our smartphones. Okay, so here if you give a photograph, okay, then it try to give a name of the photograph. Okay, a small data set, even if anyone interested in doing this, you can do this. Okay, that is, if I am seeing the photograph, immediately it will display name on the face of the photograph. This is known as the tagging on social media. And recognizing the handwriting. Okay, handwriting. Okay, this is very simple. Character recognition system, already we are familiar with this. There it will separate each character and try to understand the each single letter in a PDF file, in anything. Then it will try to combine them and understand that words. Okay, so on face recognition, these are some kind of applications of machine learning algorithm in image recognition field. Okay, then in medical diagnosis, okay, medical diagnosis, mostly the machine learning algorithm is used to diagnose a particular diseases. Okay, so in this they are mostly, okay, in real world example, they mostly for diagnosing, while diagnosing the disease, they will use as a recommender system also. Okay, that system will recommend for to a treatment option, or sometimes they'll use to recognize. Okay, this recommended treatment option may be a kind of chatbots may be used with the physician. Okay, they will keep on ask, okay, based on speech recognition, they will ask some queries. Based on our answers, they will identify, okay, the answers are, they will ask about the symptoms. For that, we will give our reply. Okay, based on that answers and queries and answers, then it will recommend a treatment option. Okay, this is one example. Or if you go in oncology and pathology and all, they will the machine learning algorithm. Already I told you, it will use an X-ray or CT scan and MRI scan, and it will try to identify whether the images are having the cancer tissues or not. Okay, so this kind of analysis can be done with this machine learning algorithm. Okay, so in machine learning, so that's what in machine learning in medical image analysis, this is our field. Okay, so in the medical image analysis, here you can see now. Here, this is inside, this is an MRI room. So in MRI room, the patient is placed in
Ma'am, your voice is not audible. Alex Shelby, ma'am. Alex Shelby, ma'am. Ma'am, disconnect ஆயிடுச்சு ma'am. Disconnect ஆயிடுச்சு.
disconnect ஆகுது. என்ன செக் பண்ணவா?
பண்ணுங்க please.
மறுபடியும் மீட்டிங் பேக் ஓகே.
இல்ல வேகன்சி இருக்கு மேம். So there's some network issues. She's joining again. So ma'am is joining again. Okay. Please bear with us. Yeah.
It's now connected. Okay.
You can continue, ma'am.
I think I've stopped with this screen. Am I correct? Am I audible?
Yes, madam. Audible.
Yeah, yes, ma'am.
The screen only, na? It's a connection lost.
Yes, ma'am.
Okay. Okay. So with this, so in a medical image analysis, many images will be produced for the patient. Okay, naturally thousands of images will be produced for the patient. Then a doctor or maybe a team of doctors, they have to go through all these images. Okay, to go through all these images in order to identify a or diagnose a particular disease or taken a treatment planning or surgical planning for anything. They have to go through all these images. But since they are having the knowledge of this, okay, expertise with that. Okay. Okay. So this expert has to go through all this. So per patient, there are thousands of images are available. Okay. So particularly in brain, okay, in human brain, you'll usually the human brain, the images, we say it as a human brain data set. Okay. So here this data set is, okay, it is naturally data set is here, it is referred as a volume because they will produce many images. As it may be a 3D volume, okay, it produces a stack of 2D slices, okay, so that's what it is known to be brain volume. So here in this analysis here, the human previously, based on his spending so many years for doing this medical course now, so he can learn everything automatically based on his experience. So he can now challenging the machine. But previously, while during the years 1980, 1990, 2000, the artificial intelligence machines were available, but they were only under the control of human order, okay, and human order, human command. But here nowadays, the machines also, they are also accepting this challenge. Yes, as like you, even I can learn the past data and I can develop my own algorithm. Okay, so with the support of the machine learning concept, okay, with the support of the machine learning concept. Okay, so this kind of science of training machines to perform human tasks. Okay, this is known to be the artificial intelligence. Okay, training machines to perform human tasks. Previously, the machines are used for doing a general task, but nowadays in medical field also, this kind of very tedious jobs like analyzing thousands of medical images, in that field also we are using these machines under this artificial intelligence concept. So here in artificial intelligence itself, we can understand a kind of automation. Okay, initially we will try to develop a kind of automation. So this automation is, the motivation of this automation is, in medical field we are using this concept for extracting or analyzing or understanding some useful information. Okay, so this medical expert, the doctors, they will try to extract something. Okay, in the image they try to extract, for example, if suppose any brain is affected by tumor, then are using this artificial intelligence algorithm, they try to extract this tumor portion, or they will try to analyze whether the tumor is a simple one or it is a cancerous one, like analysis. That kind of analysis they can do, and they can understand whether it is possible to remove the tumor with the support of surgery, or just with a simple medication we can suppress the tumor. Okay, so that kind of information and all they can extract from. Okay, they can take from these images. Okay, previously either they will use single image or a sequence of images, but all this kind of automation is now we are trying to transfer it to the machine. Okay, so that's what here we are saying this as automating the automation. Okay, machine learning is known to be automating the automation. Okay, so in artificial intelligence in medical image analysis, particularly in medical image analysis, it will support the radiologist or it will support the pathologist, because these two persons only working with images in medical field. Okay, so they use the medical imaging to diagnose a wide variety of conditions. Okay, so this AI role in medical image analysis either with the radiology department or with the pathology. Okay, so here the use of this artificial intelligence is usages in robotic surgery. Okay, so this is the robot, patient is on the table. Okay, it's a surgery. The robot is attached with the camera, and its arms it will have this instruments. Okay, surgical instruments may be fitted with that. Whereas the real surgeon here, surgeon is with this console, and this camera view is attached with him. Then the image is taken by this camera. Okay, the scanner machine or some camera attached with this robot will be passed to him. Then he will control this robot. Okay, he will control this robot through this console. Okay, so this is a kind of robotic surgery. So it is comes under minimally invasive surgery. So this is one of the popular AI application in medical field, robotic surgery. Okay, so here now we'll come to this machine learning. Okay, in artificial intelligence we are all familiar with that. It is a kind of automation tried with every field that is known to be the artificial intelligence. So here the machine learning is a subset of AI, and it is mainly concerned with development of algorithm. Okay, usually naturally in every concept we will try to develop an algorithm. Okay, and previously and all, as soon as we'll start to do our computer science course, we'll try to write an algorithm. Okay, so the same way only here machine learning also, it will try to develop an algorithm which allow the computer to learn. Okay, it will allow the computer to learn from the data, okay, from the given data. Here, given data is what? Our inputs, okay. From the given input, it will try to allow the computer to learn with the help of this data and past experience, okay. Some iterative approach also it will support to learn the computer, okay. This is the concept of machine learning. So this term machine learning was introduced into by Arthur Samuel in 1959, okay, 1959. So that's what artificial intelligence is, a broad area. So the concept of artificial intelligence is any technique which enables computers to mimic human behavior, okay. Enable the computer to mimic the human behavior using some algorithm, if then rules and something we can use. But this machine learning is a sub area, okay, subdomain of artificial intelligence. It is a subset of AI technique, but which uses statistical methods to enable machines to improve with the experience. Okay, it will enable the machine to learn and improve with the experiences. And one more under the machine learning, you'll have one more area, deep learning. Okay, it is that is nothing else, but it is one of the advanced concepts which make the computation of multi-layer neural network. Okay, that is a separate area. Today we'll discuss about this machine learning. Okay, so this machine learning enables the machine to automatically, this is main point, automatically learn from data, because we are already having this data and data analytics concepts are there. Okay, the data, we prepared the data is ready. Okay, now we are developing this machine learning. It will enable the machine to automatically learn from data. Then it will improve the performance from experience, and it will predict the things without being explicitly programmed. Okay, no need to write any programming for it. Okay, it will do everything. Okay, it will automatically learn using the data and past experience, and based on that it will improve its performance also. It will produce its algorithm, it will produce its model. Okay, so that's what in artificial intelligence, this is the years, okay, in which decade they will be popularized. Okay, so here in this picture, see this picture here, this is one kind of brain image. Okay, so this is the brain image, one image. Okay, there are hundreds of thousands of images will be produced for a patient. This is a single image. Okay, so in this image here, this portion, okay, this portion is affected by this is the tumor affected area. Okay, brain tumor. So for this, okay, this is our in 2006 when we started our work using this brain tumor images. Okay, we start to develop an algorithm to identify this. Okay, and I'll discuss it later. Okay, so in nowadays, currently, one artificial intelligence based tool was very popular in brain scan, brain imaging. Okay, that name of the tool is BrainScan. Okay, so in this BrainScan, this is used to accept the CT images. Okay, used to accept the CT images of a patient. When you give a data, a CT image of a patient, when you given it as a data to this tool, okay, this BrainScan tool, immediately it will start to analyze this brain images, okay, of this patient, and it will display, okay, it will display the kind of abnormality or kind of disease, okay, the percentage of happening of this disease happened with this patient are displayed in the screen. Okay, these are the see, epidural is one kind of disease. That possibility of disease with this scan is just 3.49%. Okay, likewise, all the possibility, what are all the possible diseases happened with the human brain, they will list out, and the possibility in percentage also it will display. Okay, so here this patient, here this yellow color is affected area. Okay, that disease is related with subarachnoid. Okay, so that's what the percentage, it is not subarachnoid, subdural. Okay, subdural. Okay, it is a dural portion. There some abnormality is there, that percentages it is given as 94.38. Okay, so this is used to support the doctors, okay, to derive the diagnostic process quickly. Okay, so in this way, this is one a very popular tool available. So this is a AI tool. It is a BrainScan CT, this kind of decision support system for the head CT scans. This is based on machine learning. Okay, this is based on the machine learning. So here it will accept the human head CT scan, and it will analyze, and it will display a kind of that is the possibility of diseases happening with the in percentage. It will give the results. Okay, for the human brain, given human brain. Okay, so the merit of this AI tool is it will enable automatic detection and classification of the pathological changes. Okay, automatically detect and classify them. So the advantage of this is this will provide the doctors with additional information. Okay, it will provide a, additional information to the doctors only. So that additional information allows the doctors for a faster and more efficient interpretation. Okay, it will quicken the interpretation. So this is the one of the advantage of using the artificial intelligence in medicine field. Okay. So in traditional programming, that are in previously, while they introduced artificial intelligence in 1960, 70, 80 and all, the traditional programming based on that, here for a system, okay, in a system, we'll write a program and we'll give the program to the system, and at the same time we'll give the data, then it will run the program, execute the program, it will produce the output. Okay, but nowadays here in the machine learning for the system, you will provide the data, at the same time you will provide the output also. Okay, you will mention the output also. Okay, so in this output for the data, this output is otherwise known to be the label. Okay, otherwise known to be the label. Okay, for the data and the label, if you are given to the computer, it will produce the algorithm, it will produce the program. Okay, so this is the concept used with the machine learning. So previously that traditional programming, we are tried with automation. Okay, we'll try the automation, but the machine learning is automating the automation. Okay, so with our research area also, 2006 onwards, we are trying all this traditional programming concept used with MRI images and machine learning, and nowadays we are using deep learning algorithm also. So in this, first I'll give the example for this. This is my Google Scholar and ResearchGate. There all our publications are there. Okay. So in this, first, while we are starting our research at 2006, here in the traditional programming, here I will explain it with a simple example. This is the brain image. Okay. So in this brain image here, you can see in the central, okay, in the brain central portion, divide the brain into left brain and right brain. Okay, cerebral hemisphere, okay, that is the major brain portion, that may be divided into two portions. Okay, left hemisphere and right hemisphere. Okay, so this left and right hemisphere, these are divided by the central vertical line. Okay, this is known to be longitudinal fissure. Okay, some mild general anatomy, that's all, don't afraid of this. Okay, this is a longitudinal fissure that will divide our brain into left hemisphere cerebral bone and right hemisphere. Okay, so this is the fact. Okay, so for a normal brain, okay, for a normal brain, when you divide this, okay, along this, usually this longitudinal fissure is treated as a vertical line. Okay, while imaging, that fissure will be fixed with this vertical line. Okay, vertical central line of this image portion. Okay, so if you check these two portions, okay, this left and right portion, almost they will be symmetric. Okay, when you check for a normal scan, along with this vertical line, they will follow some symmetrical about this line. Okay, so this is the fact used with the doctors while they are go through the scanning image of a patient. Okay, so here in this abnormal scan, you see about the vertical line here, in this up to this portion, they are maintaining the symmetric, whereas while coming in bottom, okay, while coming in bottom right, there some bright portion is there inside, but in this side it is another side it is dark only. So here the symmetric is missing. Okay, I think everyone have got my point. About this vertical line, the both side, the symmetric is missing. As soon as seeing this, the doctor can realize that something, okay, some abnormality is there with this patient. Okay, so here this scan is considered to be the deceased, the abnormal scan of a deceased person. Okay, so this is the fact used in our MRI scan used with a neurologist. Okay, so here we are taken this, we are considered this, and we try to develop a program for this. Okay, one AI program, and previously it is known as a knowledge-based system. Okay, previously knowledge-based system it is. Okay, so in this knowledge-based system, in our image, brain image, we have to identify this vertical line first. Okay, you have to these are all considered to be the data pre-processing technique. Okay, you have to identify this longitudinal line. Okay, but then using this knowledge in this knowledge based system. Okay, previously these are in now AI system are called as expert systems. Okay, so for that expert system here you have to define some, okay, something like what is your starting search space, okay, and what will be your initial state, and what is your goal state, and what are all the rules you use to arrive this goal. Okay, so these things you have to define for any kind of expert system. So we defined for this image, we have defined this, what is my search space. Okay, I defined what is my search space and what is my initial state and what will be my final state, and I have defined some rules. Okay, so for this expert system, I derived this expert system, and for that expert system here I have developed an algorithm. Okay, developed an algorithm to identify the symmetrical about the central vertical line. Okay, then using that this algorithm and the expert system, we have experimented this concept with several brain images, and we got a good result, good accuracy. Then submitted to this paper into LC Computers in Biology and Medicine, and it published. Okay, then we got two papers. One is for one kind of images and another for another kind of images, and both will be, we got a publication. But this is purely a rule-based system. Okay, knowledge-based developed. We have developed the rules based on the experts. Okay, medical expert knowledge we transferred into the machine. That's all. But later, when the machine learning algorithms are entered into the field, there in the machine learning algorithm, no need to define anything. There is no need to define expert system description or algorithm anything. Here you have to define the tumor feature. That's all. Okay, you want to find out the tumor means define the feature, how the tumor will be there in the image, just to define it. Then that feature will be used by the machine to develop the algorithm. Okay, so that is the machine learning base. Okay, define tumor feature. These two concepts no need. That is, brain is symmetrical about longitudinal fissure. It separates left brain and right brain. No need to define anything. Just to define the tumor feature. Okay, this is the tumor portion now. So here how it will be. Okay, give the statistical parameters or something. Define it. Define the feature of the tumor. So for that, used that feature. Okay, this is the machine learning algorithm development. Okay, so in this machine learning algorithm development, there are two concepts. One is the training, another one is the predicting. Okay, so in the training, here we will give the input image with the labels. Okay, here my labels are whether in the input image, what type of image is there. Okay, what type of tumor, whether it is a benign tumor or malignant tumors. Okay, likewise I have to define the label for the image. Then that for that image, it will extract the features. Okay, it will extract the feature. This will be defined by the programmer. Okay, it extract the features. Then from that feature, it will generate the feature vector. Then it will be, that vector will be given to the machine learning algorithm. Now, based on that feature, the machine learning algorithm that will be trained. Okay, that will be trained, and that will be select the best algorithm. Okay, best model. It will be select, and it will produce that model for the prediction, future prediction. Okay, in the future, once the best model is fixed, then we can give a new images as for to predict the result. Then for every new image, it will same way, it will extract the features and it will construct the vector, and it will use the model, and it will display the predicted labels, whether the new image is a benign image or malignant tumor. Okay, so this kind of testing also algorithm also we have developed. Okay, so the title of our algorithm article is a machine learning approach for automatic brain tumor detection using patch-based feature extraction and classification. Okay, there are so many feature extraction algorithms are there. Okay, here we are using patch-based. Okay, images already I told you, digital image is treated as an intensity matrix of intensity values. Okay, so in this matrix we are taken as a patches. Okay, patches wise we have taken. And in each patch, we have generated some features. Okay, we extracted some feature and we tested. Okay, so this article has been published in Journal of Biomedical Engineering and Technology. Okay, then in later, while in 2021 and all, I think you all familiar with this Nature journal. It is one of the topmost journal in research community. So in that, an article arrived in 15th Jan 2021. It is a kind of a review article. In that, it concluded that in brain imaging, deep learning beats the standard machine learning. Okay, so the deep learning models, they can able to detect patterns and discriminative features in brain imaging better than machine learning algorithm. Okay, they proved that. Okay, so what is the difference? Now you have to familiar with this. What is deep learning? Okay, how it will be differ from the machine learning? Okay, so for this here in machine learning, this is the process. I have already explained this. When you give an input, it will here we will have to support the feature extraction process. Okay, because we must have some domain knowledge. Based on that, if we suppose tumor means for tumor feature, how the tumor feature will be. Okay, for that you have to draw some feature extraction process. Then that features, once you given the features for the machine learning algorithm, then it will do the classification. Okay, that is the base for machine learning. But whereas in deep learning here, deep learning just to give the input. Okay, the next two steps, the feature extraction, classification, everything will be done by the machines. Okay, everything will be done by the machine. There is no need to involve the human here. Okay, then it will produce the output. Okay, so this is the concept of deep learning. So when you use, suppose if you want to use this deep learning, same deep learning I want to use in my process. Okay, the same way to identify the diseased scan. Here, the previous traditional concept, no need. Then machine learning feature defining tumor feature also no need, because it will do, the algorithm will do, deep learning algorithm will do the feature extraction also. You just give the scan image, then it will tell whether the image is affected by the tumor or not. Okay, so this is very peculiar thing actually. Here, see, this is a kind of image, dog images. Okay, puppy dog, it's a one position, a dog position, sleeping position. But if you train a deep learning algorithm with the kind of puppy dogs, when if suppose you are given a input as a beagle, kind of beagle, see here in this image, second image, 4 to 1, first in the second row, first to 1, these are the beagle. Okay, suppose you are given this, it is a sometime it may be classified it as a puppy dog. Okay, that is the choices are there. So that time the training is very important in the deep learning. Okay, leave it, because today I'm not going to tell anything about the deep learning. Okay, so whatever be in machine learning and deep learning, almost all the concepts are, all the architecture, everything is available. Here your job is, you are having a data with you. Okay, and perfect data is in your hand and adequate data are in your hand. Then your job is, as a researcher, you have to choose a kind of architecture. Okay, you have to develop a kind of deep learning model to analyze those images. Okay, so the proper architecture and objective function should be selected according to the data considered. Okay, they should be selected according. So once again here, what is your role? You have to concentrate with this data concept. Okay, so here the data means they may be any medical data, may be collected from healthcare, or data collected from food industry or agriculture or biotechnology, anything. Okay, so here data is important. So that's why the data science become very popular nowadays. Okay, so in this data science, the one part is machine data analytics and machine learning. So this machine learning learns from the past, the historical data. See here, training, input, past data. This algorithm, it will learn from the data. Okay, you're giving the data based on training, it will learn, then it will produce a model. So when you give a new data, it will automatically, this model will produce the output. Okay, it's similar to a human person. Okay, so this is the concept in machine learning system. So that's what, while suppose you are using machine learning in data science and data analytics, the life cycle is you'll get data and pre-process them, train the model, and you have to test the model. Once the training and testing you are satisfied with that, then you can naturally try to implement the model. But before that, suppose if you want, you can improve the performance of the model. Okay, so input data, pre-processing, train model, test model, and improve. Okay, so in this data collection is one of the foundation of the machine learning. This is one of the main concept. Collecting data is considered for the foundation step. Okay, so while collecting, you have to concentrate with this relevant and reliable data. Okay, it is very important because they will have a direct impact of your output. Okay, so you have to collect the relevant and reliable data. Then next is data cleaning. I already told you that this data cleaning is nothing else, a kind of pre-processing, preparation process or pre-processing concepts. Okay, and at the same time, okay, you will do some pre-processing with your data, either with the textual means, you can avoid some missing data and you can avoid unrelated data. Okay, that concept. Or images means you can work with noisy images, you can work with blurred images, those things and all you have to correct it. Okay, data cleaning. Then after that, you have to convert all the data into a single format. Okay, same format. At the same time, you will preparing data here, you have to concentrate with this splitting data, because here while developing machine learning model, here two steps are very important: training the model, testing the model. So you have to decide while preparing the data itself, you have to decide how much data you will use for your training and how much data you can keep for your testing. Okay, that you have to decide during this data preparation. Okay, so first collect the data, then prepare your data. Then after that, train the model. Okay, train the model where your natural, that is the machine learning, starts at the model. Okay, so this learning training time, it will learn. So the training data set is used to predict the output. Okay, so this predict the output, actually it is a kind of iterative process. Okay, in each iteration it will improve its prediction accuracy. Okay, so this is like a practice given to the machine, how we will train our sportsman or giving coaching to our children. Likewise here for machine also, in the during the training you have to repeatedly, you have to do this for improving its accuracy. So it is a iterative process. Once you are satisfied with this accuracy, then there it will stop and the model will be produced for the prediction. Okay, then model evaluation. Okay, after completing the training, the model evaluation will be done with the testing data, because in already in data preparation you have kept some data for testing. Now the data will be used for this model evaluation. Okay, so once it is success with this testing process, then it will be placed into a real-time application. Okay, then finally this implementation, that is prediction. Okay, in that time also, okay, model is trained and evaluated now, but we cannot say that it is a perfect, because in sometime for with any kind of new data also, it may
There's a network problem again, I suppose. Yeah, connection lost. Just a minute, I'm asking her to join again. Yeah, the connection is lost, so she's joining again. Just give us 2 minutes.
Okay, madam, I'll share my screen.
Yeah, she's back.
Okay. Am I audible?
Yes, ma'am.
Yes, okay.
Yeah, this is your slide.
Yeah. So in the prediction time, okay, it will not be perfect sometime. Okay, that time you can use this tuning concept. You have to tune the parameter. Okay, so this time in this tuning process, a researcher can work. Okay, tuning the parameter. There are so many concepts are available for optimizing the parameter. That concept is available. So you can implement, a researcher can implement this concept in your research work. Okay, so these are the 5 steps involved in the machine learning process. Okay. And next thing is how to get data set for machine learning. Okay, how to get my data set? How can I arrange the data set? Okay, so first, I think you're all familiar with this. What is a data set? Data set is nothing else but a collection of data arranged in some order. Okay, in image processing, a image is a collection of pixels, okay, arranged in a matrix form. Okay, the collection of pixel intensities, okay, pixel intensity may be in black and white or in color value, arranged in a matrix form. Whereas this textual data, they will be arranged into a tabular form, okay, table form. Okay, so in this tabular data set, actually it may be a table or matrix, anything here. Most common format is CSV format. Okay, but nowadays the mostly some of the data sets, they are using this JSON tree like data format. They are using very advanced programming. They are using in Python programming this JSON file format. Okay, there are so many types of data sets: numerical data, categorical data, ordinal data. Okay, based on that you can choose your algorithm. Okay, so here we have to understand what is the need of the data set in machine learning. Okay, so once you collected your data set, okay, before you're going to implement the machine learning, you have to divide them into, okay, divide the data set into training set and test set. Okay, so in the training set, again training set and validation set and test set. Okay, so in this way you have to divide them and you have to use it in your machine learning. And there are so many popular sources of machine learning data sets are available. We are very lucky actually nowadays, current researchers are, because previously while doing myself, I'm doing, while I did my research, I have to visited so many hospitals, okay, in Kerala, Bangalore, okay, and Madurai. I visited the MRI centers and I collected the materials. But nowadays, almost all the kind of data are everything, images, or social media data set, or normal data set, everything is available, or food industry data set, agriculture data set, everything is available with the popular sources or public data set are available. So in this, one of the very popular data set is Google data set. Okay, any kind of data is available in this Google data set. This is the website. Okay, now, most of the machine learning algorithms in Python, they will use this Google data set. Okay, you can download and use it, or sometime if you have your own data set you are created by your own interest, then you can publish the data set in this website also. Okay, they are supporting them. Okay, then after that, here there are so many algorithms, machine learning. I told you, there are so many algorithms are available. So for doing this machine learning, developing a machine learning model, here these algorithms are divided into 3 categories: supervised, unsupervised, and reinforced. Okay, here the concept is for supervised. If suppose your domain is, your application is task driven, that is you have to predict the next value. So that in that way, if you want to do, then you have to go for supervised, or unsupervised is a data driven. Okay, just data are available, that's all. So from the data you have to do some clustering, some grouping you want to do, then you have to do this unsupervised or reinforcement. Okay, reinforcement is a reward based, that is learned from the mistake. You can train your robots and everything. Okay, reinforcement learning. Okay, so in this supervised learning, again there are we can do way you can do, whether you can use this classification or regression. Unsupervised is mostly used for grouping, clustering only. Reinforcement learning is for model based and model free. Okay, there are again subdivided. Okay, so these are the some of the base difference among them. Supervised is input data is called the training data, has a label. Okay, supervised is always the training data will have a label, but whereas in unsupervised they are not labeled. Okay, they are not labeled. Semi-supervised is by name itself, it is a mixture of both labeled and unlabeled data. And this reinforcement label is reward feedback. Okay, so this is the concept used with each learning. There are so many algorithms are available in each learning. K nearest neighbor. Okay, so supervised means K nearest neighbor, decision tree, neural network, support vector machine, SVM. And here for unsupervised also, unsupervised, K means clustering. Okay, I told you, K clustering algorithm. K means clustering, self-organized map Okay, and PCA, these are all comes under unsupervised. Okay, likewise semi-supervised maximum likelihood learning generative models. Okay, and reinforcement, these are algorithm, already built in algorithm, they are available. Q-learning, multi-armed bandits, Markov decision process, these are the algorithm. In the last line, a kind of application can be used with this, algorithms are given. Okay, so in this machine learning types here, once again, the same graph only is given. Okay, so in the, from the classification, you can understand regression, classification, clustering. These are the common terms used with almost all the learning. So in this, regression, classification, and clustering, these are the three key machine learning algorithms in data science. Okay, so the base difference among these three is regression. Actually, the regression is okay, it's not given. Regression is always used with this continuous data. Okay, regression is always used with the continuous space. Okay, so here you'll try to fit this line. Okay, y equal to mx plus c, you try to fit this mathematics based on this mathematics. Okay, so here y equal to a best fitting this curve is identified and used this, then they will be classified. Okay, so regression, the popular regression algorithm are linear regression, perceptron, neural network. Okay, so these are the popular algorithm. Classification is mostly used with this discrete values, whereas in regression it used with continuous space. Here it is used with the classify. Okay, you have to classify, you have to differentiate the data into some classes or categories. Okay, so here instead of y equal to mx plus c, here they will try to finding the curves. Okay, a curve shaped this fitting will be tried with this classification. Okay, there are these are the popular algorithms: support vector machine, neural network. Okay, naive Bayes, logical regression, k nearest neighbor. These are the popular algorithm. Clustering is grouping. Okay, clustering is the grouping. So this is the grouping concept. There are 5 groups are possible with this data. They try to group them. Okay, so this is given in the clustering concept. K means clustering, fuzzy C means clustering, agglomerative clustering. There are so many clustering algorithms are available. Okay, so that's what here in machine learning you can you work with either a continuous data or categorical data. Okay, using supervised learning, unsupervised learning, reinforcement learning. Okay, in supervised and unsupervised, supervised you will have regression, classification. In addition to this, you will use the decision tree and random forest. Unsupervised clustering. Okay, so this is the classification. These are the popular. Suppose you want to know the in-depth of this algorithm, the concept used with this algorithm, if you want to know, and it's very simply given in this Java Point website, you will go through this. These are the popular algorithm. You just go through this. Okay, these are all are a built-in algorithm. Okay, you just understand the concepts of this. Okay, so in order to understand this concept and for using this, the skills used for is the fundamental knowledge of probability, statistics, and linear algebra. That's these three qualities are enough to understand this algorithm, and the ability to code in any computer language, especially in Python language. Python is the best language for machine learning algorithms. Okay, and a knowledge of calculus, especially derivatives of single variable and multivariate function. Okay, this you have to understand. Whether you are going to work with the classification or clustering, there you have to define a kind of the variable, type of variable, whether it is a single variable function we are going to derive, or we are going to work with the multivariate function. Okay, these are the very base knowledge you have to understand to work with the machine learning algorithms. Okay. And this machine learning algorithm, usually what we will try to understand is, if suppose I want to go to learn with, okay, go to view some machine learning algorithms, I try to read the algorithm and identify how this algorithm works. Okay, but for machine learning algorithm, don't go for how. Okay, here while choosing this algorithm, you have to keep 2 points in your mind. Okay, for what type of problem you are going to work, and why you are, that is what kind of pattern you want to derive from the data. Okay, what kind of pattern you are going to derive from the data, and what is that that is problem statement you have to concentrate. Okay, so here the first one is, suppose in your data, you want to classify them into any of 2 groups. Okay, so this, what is this data? It is whether it is A or it is B. Okay, so that is popularly known to be the binary classification. Okay, so in your hand, you are having a data set. From the data set, you have to identify whether this data is belongs to group A, and that is A or B, binary classification. So for this classification, this kind of domain, okay, here the machine learning algorithm, just either you can use logistic regression or SVM or K nearest neighbor or classification decision trees are available. Okay, you can directly choose this algorithm and you can work with that. Okay, so this is the concept. Or if suppose from my data, I have to identify whether the data belongs to, okay, maybe belong to more than 2 groups, okay, more than 1 group. That is, it may be belong to A or it may be, okay, B or it may be C. In that way, it is known to be multi-class classification. Okay, that is known to be the multi-class classification. If you want to work with suppose for example, suppose a fruit type identification system or tumor type identification system. A tumor may be the tumor type. There are 4 grades for each and every tumor. They may be belong to 4 grades are there. Suppose I want to identify in which group the tumor grade it belongs to. Okay, in that way, then I can choose, okay, random forest, classification decision tree, XGBoost, K nearest neighbor or ANN model I can choose. Okay, so based on the domain you can select. Okay, then next is a continuous form. How much or how many of something I am expecting. Okay, I already told you for continuous space you have to naturally have to go with the regression algorithms. Okay, linear regression or regression decision tree, XGBoost or ANN. Almost ANN are involved with each and every concepts. Okay, then next is whether I have to classify a data, whether this data is normal or no, it is abnormal. In that way, then that is to identify some kind of outlier or some kind of anomaly or abnormality detection, then I have to use this isolation for a density based. Because why I am telling this is there are so many machine learning algorithms are there. Okay, you cannot go and try with all the algorithms. So that's what first you have to, anyway, you will be familiar with your data analytics and the data problem domain. Everything is familiar to you, okay, before starting to choose your machine learning algorithm. So based on that concept, you try to choose your machine learning algorithm. Or suppose if you want to organize your data, you want to group your data, that is clustering concept. Okay, naturally you will involve with this clustering. So here we will go with the K-means clustering, mean-SIP clustering, okay, the agglomeratic hierarchical clustering. So many clustering algorithms are you can choose and you can work with that. Okay, otherwise if suppose if you want to know what will be, what I can do in the next, okay, based on the outcome, then the decision will be taken, then I can proceed in that kind of applications. Okay, in that kind of trial and error multi-feedback application, there you can go with this reinforcement algorithms. Okay, reinforcement level of algorithm. That is the best example is self-driving car. Okay, nowadays the self-driving car application is very popular, but the decision, okay, the decision is based on the event happened with that. That is that based on that, then it will take the decision. Okay, that is the reinforcement learning. So with this, in this way you can choose your machine learning algorithm. So in the machine learning algorithm, if you are given a input, there are so many algorithms are available. Based on that domain, you choose your algorithm and try to develop your model. And one more subdomain of machine learning is a deep learning, but today I'm not going to take this. Okay, I will show you some more example, okay, for you to explain this machine learning algorithm. Shall I proceed or it's over time, Lavanya? Dr. Lavanya?
Yeah, we can open for questions, ma'am.
Okay. Any questions? Because in our group, we are working with the 2 kind of application. One group is working with medical imaging and another one is working with this food processing unit, Mango quality grading system we are developing. Okay. Okay, any questions?
Participants, any questions?
Yes, madam.
Yeah, please.
There you use the K-means clustering. What is this K terminology?
Clustering means grouping, no sir. So if suppose from the data I want to group 3 groups, or 4 groups or 5 groups, the number of groups is K. How many groups if you want to derive from your data?
K, the terminology, what is this meaning of this
Number
K?
of groups.
Why not Y?
K is the number of groups. K is the number of groups. If
Okay,
suppose I am working with a mango grading system. So in that first I have to identify the mango type. If suppose in my data set I am having 5 kind of mango types are available, then I will fix K as a 5.
So we can consider K as Y or Z, any other.
Yeah, you can use K is just a term K.
Okay, there is no any significance of K terminology.
No, sir. To my knowledge, no.
Okay, thank you.
Okay. Any other questions?
Yes, good afternoon, ma'am.
Good afternoon.
Hello.
Ah.
Yeah, I'm Sakib.
Hmm.
Please let me know about have you used a deep learning model in your approach?
What? Pardon, sir. What is your question?
Yeah, have you used deep learning approach in your work?
Yes, yes, sir. We are working with medical image analysis, brain tumor image analysis. We have used some kind of CNN models for the tumor classification. We have used
tumor classification. Yes, in CNN approach you have used, yeah?
Yeah, CNN approach we have used. And also we have used UNet and ResNet and all for tumor segmentation also.
Okay. Is there any experience about the in transfer approach?
What, sir?
Is there any experience in transformer approach you have used?
Oh, transfer learning you are telling?
No, transformer. Basically, this was used in the text data. Now is applying on the images also. So have you used in transformer?
I think I got your question. Transformation. Am I correct?
Yeah.
Transformation is actually, it's a very good concept nowadays used with the image processing, because mostly image processing we are working with the spatial domain. But for some kind of feature extraction, we have to convert our images into some other domain. For example, wavelet transformation and all we can use.
Okay.
Wavelet transformation, that is a very good concept used with the compression, denoising and all, it will be used. We can use, sir. Very well we can use. Even you can use a frequency domain, fast Fourier transformation. There are so many transformations are there we can use.
Yes.
Even my group is working with the wavelet transformation for one analysis. Okay, sir. Thank you.
Okay. Thank you.
Any other questions from the audience?
If UGC HRDC permit, then I will take my next session as deep learning in future. Dr. Lavanya.
Yeah, we'll definitely use your resource, ma'am.
Okay.
We'll definitely use the resource.
Okay.
Ma'am, in your experience, what you find is a good tool for data analytics in medical image?
Data, Python only.
Python.
Python only. Previously, we were working with this MATLAB. MATLAB also a very good tool, but it is since Python is an open source, it's dominating.
Ma'am, are you using any GUI based application for processing? Suppose you are using the MRI data or CT scan data. So for slicing purpose or for 3D analysis, you are using the graphical interface or graphical user interface application?
Sir, actually there are so many open sources available to extract the 2D slices from 3D data. MRI crop, MRI crow, so many data, so many tools are available. But nowadays, the image set itself, they are given the images as a 2D slices images. We can directly select them and we can run the deep learning models in Python. No need to go for that. And one more thing, once we completed our algorithm, I'm happy to say that we ourselves are developing our own guide tools.
Oh, guide tools. Oh, super, ma'am.
Okay. Soon we will bring them into our website, our own websites. That time I will explain that also. Our standalone tools we are developing. There we will select the image and we will run our model. Then final output it will display.
Oh,
Like a tumor, no tumor, kind of tumor.
Yeah, it's great.
Tumor
I
brain.
think. Yes.
Yes, sir.
all the best, ma'am.
Thank you, sir. Thank you, Lavanya. Okay.
Any more questions, participants?
Ma'am, one question, ma'am, from Radhalakshmi, ma'am. Ma'am, can you hear me, ma'am?
Yes, I'm here. Okay.
Ma'am,
Yes,
ma'am, what is the recent trend in doing the analysis for outlier, ma'am? Detecting the outliers?
Detecting outliers, it is depends on the domain in which you are working. Outlier detection in textual data, outlier detection in images, and even outlier detection in remote sensing data also available.
Okay.
Are you which area are you working?
Ma'am, I am working in clustering commonly, ma'am. Just now I have started my research work and I want to know what is the trending in outlier. Text, ma'am.
Actually, that
spatial data.
Actually, this outlier you can do this work in two ways. One is as a pre-processing you can do. Okay.
Okay, ma'am.
Otherwise, you can let them to enter into the model and the model will try to separate the outliers. There you have to define your problem. You have to clearly define your problem. Okay.
Okay.
Both are possible.
Okay. Ma'am, one more doubt, ma'am. Whether I can implement in KN, and that is neural networks, ma'am?
K nearest neighbor, KNNS.
Yes, neural network, I can do it, ma'am, using fuzzy logic.
Yeah, you can do it. Neural networks, you can do it. That is separate. Okay. That you can do it.
Okay, ma'am. Okay, ma'am, can you tell me the tool which is the best efficient outcome for that, ma'am?
Yeah, but if you are asking tool means I will always say Python.
Python. Okay, ma'am.
You learn Python and try to implement the algorithms in the Python. Okay.
Okay, ma'am. Okay.
Ma'am, there's another question in the chat box. It says, ma'am, can you highlight on inputting the missing values?
Highlight on inputting the missing values. Handling missing values or inputting the missing values?
Inputting missing values. Maybe it is handling. That's what
handling missing values. Okay, handling missing values depending on the kind of data. If suppose you are using the numerical data, for example, if number of children, okay, number of children we are giving input in house wise. If suppose in some houses the value they are not given any value, we cannot take it as a 0 because there it may be a missing value. That time some kind of statistics we can statistical kind of that a minimum value, maximum value or average value can be filled in that place. Okay, that is with the numerical data. In images and all, if suppose in particular pixel value is not available, we will take the neighbor's average as the pixel value, missing value. Likewise, we will handle the missing value. The handling missing value is purely statistical methods only. Okay, interpolation or some statistical concepts, mean, average, median, likewise. Okay, I think I answered his question. Okay.
Any more questions, participants? Okay, ma'am. Thank you. Thank you so much for your inputs.
Okay.
Yeah, a couple of minutes for a formal vote of thanks, ma'am.
Okay. Thank you.
Thank you, ma'am. Thanks for your informative and crystal clear explanation on each topic. Really, it is very interesting, ma'am. We are eagerly waiting for next sessions from you, ma'am. Thank you so much.
Okay. Next session, I will try to give my research area or some demo area for you. Okay.
Thank you, ma'am. Thank you so much.
Thank you, Dr.
Thank you.
Lavanya, for giving this opportunity. Thank you so much. Okay.
Thank you, ma'am. Thank you so much. So, dear participants, kindly fill in your feedback form, and we are going to start our next session.
Small steps in right direction is good than big step in wrong direction. Now I request Dr. B. Lavanya ma'am, Associate Professor, to introduce our resource person for session 2.
Yeah, welcome, ma'am. Welcome, Mini ma'am. Mini ma'am.
Yeah. Thank you,
Yeah.
Lavanya.
Welcome, ma'am. Yeah, it's my pleasure to introduce our resource person for the second session, Dr. D. Mini. She is an associate professor and head in the Department of Computer Science, Madras Christian College, Chennai. She has completed a PhD from Bharatiyar University, Coimbatore. She has 30 years of teaching experience. Her area of research interest is data mining. She has more than 8 publications in national and international journals. She is an expert member of Board of Studies, Board of Examiners, academic audits, staff selection committees, examiners for few colleges and inspection committee, and a university nominee for Board of Science for Computer Science of University of Madras. She designed a curriculum for 11-month India window program of Sungkong-fu University, South Korea. She has chaired in various national and international level conferences. We are very honored and happy to have you here, ma'am. This session is yours.
Thank you, Lavanya ma'am. Okay. Are you able to see the screen, ma'am?
Yes.
Okay. Thank you, ma'am, for giving me the opportunity. Actually, I was under the impression that the students will be primarily be attending the program. But when I was listening to the end part of the first session, it looked like real senior research fellows are attending the program. I don't know how suitable it is because I prepared it as a beginning material for those who are starting their research and work in data analytics.
Every session will have some takeaways, ma'am. So
okay. Thank you, ma'am. Okay, so it's starting. So what we'll be seeing is some basics about data science, data analytics, and what we mean as domain knowledge and application of data analytics in some domains. Okay. So this is the main part we have to be comfortable with or to know with when we are starting data sciences. Say data science is a convolution of computer science, mathematics, and the domain knowledge. So if it is just computer science and mathematics or statistics, we'll be ending up with just machine learning. That is, we won't be touching the data. And if it is just math stats and the domain, then it will be a data analysis or a research. And if it is the domain expertise and computer science alone, in that case, it will be a traditional software or software development. It will be like that. But when we put all the three together, we arrive at data science. So what I'm trying to say here is, yes, we need mathematics, statistics, we need computer science, and we need the domain expertise also be an expert in data science. So this another diagram in which I've included the communication also as playing a major role in our data scientist. So without that communication, we'll be having math, statistics, programming, and the domain knowledge. So we have the data science, but for a perfect data science, if you have good communication skills, you can really score well. Okay. Some industries that are benefited from data science: education, healthcare, manufacturing, banking, government, etc. So basically, they will be forming the domains from which you will be applying the data analytics concepts. And some applications, like in most of the cases, you'll be concentrating on fraud and risk detection. And the main domain we concentrate on is healthcare and so on. So we'll visit that later. So once you learn something about data science, then you can be a data scientist, analyst, ETL engineer, and so on. The skills required, the basic statistics, probability, and some mathematics on linear algebra, and some languages like Python or etc. And you can get information about data science, data analytics from these sites. I find this Kaggle very useful. Coursera has a lot of courses which you can learn from, and Udacity, KD Nuggets, and so on. So you can refer these sites if you are new to data science and you want to explore on the projects for your case studies also. You can get data sets from them. Kaggle has a rich collection of data which you can take. You see, Machine Laboratory repository also has data that also you can take. And some algorithms that are used in data science, say regression and all, that will directly come under your data analytics. And this K-mean clustering and others will come under data mining. Okay, I hear some cooking going on. Something is cooking. Okay, so as ma'am said, I'm also endorsing her that Python is very good for your data analysis. So go for Python, learn from the basics. And these are the libraries which you can use for various purposes for data analysis. Then what we mean as data analytics, it's a process of examining data in order to draw conclusions about the information they contain. So this is the main base of data analytics. I can just show you a very simple example. I think as a kid, you would have used this for something like word search. Say, supposing that you see something like this, you're not able to get any data out of it. But supposing that you have some hints, and then you may be able to identify what are all the words that are there. Then again, you have to search for it and you have to identify. So you can look into this, say it has word search, it has vertical, horizontal, backwards, and all that words. The words are kept inside this letter box. So if you just look at this, you're not able to identify anything. So our data analytics is something like that. We have data everywhere, but we don't have a mechanism. See, if you don't have a mechanism to find some information from that, then it will be just a jumble of, like the jumble of letters here. You'll be having all the data and it will be of no use. So then what is data analytics? So to start with, what a data is, it's set of values of qualitative or quantitative. So you have two types of variables. Quantitative variables are numbers. So for that, you have quantitative data analytics, and the qualitative ones are primarily they will be text oriented, but you have sound, you have videos, and you have the images. They all fall under the qualitative variables. And from this data, if you can get some meaningful results from that, it will be your information. So in data analytics, you examine the data sets and you arrive at a conclusion about the information it contains. So it has so many steps. So you have to inspect, you have to clean, you have to transform, and you have to model, and then you have to arrive at conclusions, and that has to be communicated to the user. So different types of data analytics. You have the descriptive, diagnostic, predictive, and prescriptive analytics. So they concentrate on mainly 4 different questions, like from the data, are you able to identify what has happened, and why and how it has happened, and will you be able to predict what will happen, and so how can you make it happen, or what actions you should take to make it happen. So these are the 4 major questions. In each domain, you can apply this question and you can analyze the data. So the life cycle, so you identify a problem. So what is the problem you want to solve? Again, it depends upon the domain you take, and so what is your question, for what you want an answer. So you identify a problem, and for that problem, what is the data that is required? So identify the data, collect the data, and if the data is not pure, you clean the data, and you may have to go for data wrangling, or you may have to transform the data into a format that is required for your process, and you try to understand the data. Then you may form some models using clusters or associations, or you may go for forming a hypothesis, and then you just implement and evaluate. If it is hypothesis, you test the hypothesis, and whatever result you are getting, you just give that as the whether you have reached the goal or not, you share it to the team or the user. So here I'm just taking one small case study work done by one of my students a few years back. This is just to show one simple example, as well as that is why we need the domain knowledge. Okay. So in this system, so this data is taken from Kaggle. So you have some details about the Black Friday sales. So you have gender, age, occupation, city category, and how many years you are staying in the city, and what is the marital status, category types, and what is the purchase amount. So this is a sample one screen of the data. So using this data, you try to analyze, and here this says that most of the people who are buying are between the ages 18 to 45. Many are buying. In other ages, less people are buying. And you get some information as men buy more, contrary to the statement that women buy more. So for this Black Friday sales, men buy more, that is more number of men buy, and for more amount also they buy. So then you get some information as that is what is the role of the number of years a person is in the city and the sale amount. So it is found that those who are staying in the city for 1 year, they are purchasing more, and all others, they purchase less. So it could be like those who have just joined, they may not have decided whether to stay in the city for a longer time or not, or others like more than 1 year, they must have made the decision and they would have purchased the item in the previous year itself. So this you can conclude from this result. So, okay, so I'll skip some of this. Say something like you can classify. Okay, this another one. So you can form a heat map for the data. So here you could see that this is used for the correlation. So you could see the positive correlation and the negative correlations. So the correlations are given as, say, between product category 1 and 3. Say you could see that there is a negative correlation. So it's something like if somebody is buying first one category of item, they are buying less of another category of item. And there is a link between the marital status and age. There it is a positive correlation. Something like as the age increases, the marital status, say 0 means not, that is single, and 1 means married. So it is increasing. So it is showing a positive correlation. And another result we got is with the product and the count. But here we don't have the additional information as to what these products actually are. Okay, say all are de-identified data. So this knowledge is not there. We are not able to group what kinds of data are sold more. So even though we are having some data, we applied some techniques, we are getting some results, but we are not able to understand what it is. Similarly, we have some details about some occupation. So occupation 4 has this much of purchase, occupation 6 has this much of purchase, but we don't have the information of what this occupation is. Okay, what this occupation specifically is. And similarly, when the results are summarized, occupants 4, 0, 7, and 1, they made more purchases, but we don't know what these items are. The same way, most sold products P00265,242, but we don't know what that product is. So this just brings to the point that very simple example that we need the domain knowledge. Okay, so you need the domain knowledge when you are working with the or when you are going for data analysis. So I am bringing this diagram back. So you are having, say, computer science, that basics coding, preferably say in Python, that is required, and math statistics. So here you have your mean, median, mode, your t-test, and your hypothesis test, correlation, regression, and all that, and the different ways of visualizations, say using your bar chart, pie chart, donut chart, and all that. Along with that, you require the domain expertise or the domain knowledge also. So what do you mean by this domain knowledge? So it's referred to the background knowledge of the field or environment to which the methods of data science are being applied. Okay, you need it to define a problem, to understand the data, and to find out what are the methods to be applied. Okay, and when you get some results for that, again you need it to interpret the results. Okay, to understand what the results are, you need the domain knowledge. So I've just considered few domains or some examples for data analysis. So I've taken healthcare, finance, banking, insurance, education, agriculture, social media, and I've just thrown light on what are the main points to consider when you are going for these domains. Okay, so for healthcare, so you can concentrate on finding cure for diseases and for early disease detection, and the patient details, you can document them clearly and so on. So this healthcare, it's a process of analyzing the data to predict the trends and manage the spread of diseases such as this COVID-19. So it covers a broad range of business and it offers insight in both the macro and the micro level. So macro and the micro in the sense, say even for an individual patient, for an individual test, for the individual result, what is that analysis you can do? Say the person would have come for one specific date and time. For that itself, you can do some work. Or for the entire hospital, how you can manage the hospital, how you can service the patients, and still how you can get your profit also out of it. So all that. I'm not able to hear, ma'am. Okay, is anyone trying to speak with me?
Ma'am, you can continue.
Okay, okay. I thought somebody was raising some doubt or trying to say something. Thank you. Okay, so for the patient care quality, clinical data diagnosis for everything, we can consider. And some research and development, they provide some solutions and clinical data that can be analyzed, and what is the customer feedback or what the patient and the client feel and how they react to the treatment. That also has to be tracked, and you can identify people with high risk and they're having some chronic illness, and if that can be detected at the beginning stage itself, you'll be able to save the person. And for the hospital administration part, they can think about scheduling a physician, like when the doctor should be available. Say you would have seen that hospitals, they have some visiting doctors, they will come on a specific time, and for some time they will visit the hospital. They'll be there for 2 hours. But how are they scheduling that? Okay, so they will be using the number of patients who are arriving, and they'll be requesting for a service. So they will make a note of it when they are scheduling the services of a physician. Of course, the physician's availability, quality, all that also plays a role. And a hospital, if they want to service the patients, they should reduce the patient's waiting time, and the doctor's records and the patient's records, they have to be taken, they have to be processed. And so when somebody is coming to the hospital, a correct physician should be available for the physician to see the doctor. In case of emergency, immediate care is to be given. Even otherwise, the right doctor should be available so that you can retain the customer. And you can do some work on the patient satisfaction. Say that you can find from getting some feedback from the patient. And of course, they are coming back again. You can make a note that the patient is happy. So why they are happy, those details you can track and you can use it for improving your system. And for insurance, this plays a very important role in healthcare because the insurance companies, again, they want to make money. Okay, so we clients, we pay premium to the insurance company. We are hoping that in case of a real emergency, the insurance amount will be useful. So, but the insurance company will be interested in having getting some profit, right? So they have to identify the clients with higher risk, and for higher risk, they may have to fix a higher premium. But how are they fixing it? For that, some analysis has to be done, and they should be able to identify a fraudulent claim. Say, supposing they say that they spend so much and they're producing the bills, you should be able to identify whether it is correct or not. Okay, so you can do that with the past records of other clients, and you can find out whether it is deviating very much or it is in alignment with what has happened already. Okay, you can simply find whether that is what is the deviation of it with the rest of the records. And you can identify, or a insurance company that can identify a high value, low cost health provider, meaning that they can identify a hospital for providing the healthcare. Because then sometimes what happens is the hospitals, when they know that you are having a say health insurance, they will just charge any amount or give any treatment, and they'll be extracting money from the insurance companies. Okay, so the insurance companies are wary of these hospitals, so they have to identify a good hospital that will give a good service to the client, because that will retain that client as well as bring more clients to him. At the same time, should not be cheated. So some benefits about the clinical treatment, speed of identifying patients, etc. So this we have seen. Then the next one is finance. So finance, we see about the risk, some consumer analytics, and personalized services. Again, this fraud detection and so on. So here, this data analytics should help the finance executives to transform the data into some insights or some ideas that will help them to make a good decision making. Okay, so you have to identify the areas in which revenues can be generated. So some insights has to be given. Okay, we can invest in this area and this will give us profit, and this will give a loss. Okay, and what is the cost of amount paid to the workers or the employees, and how much of money we are getting from that service. So all that has to be processed. So again, they have to find out whether there are any fraudulent transactions. And next one is in banking. Again, here also you have to think about risk and fraud detections, and identify customers, retain customers, and so on. So you have to improve the bank's services, and say nowadays banks are desperate about retaining customers. Say those days people run to banks, but nowadays banks are running to customers. So you have to identify the services that are provided to the customers, whether they are happy, will they just close and go to another bank. You have to think about the competition. So you have to identify what is the, see the rate of interest, others are fixed by RBI. Some of things you can't change, but some other facilities you can improve and give to retain the customer. And of course, the credit card frauds and all that you should be able to identify through this analysis. Then through the insurance, see we have seen insurance role in healthcare. Now we'll see about the other types of insurance, like life insurance, house insurance, the vehicle insurance, and so on. So the customer's data you have to manage, personalized service you can give, identify the risk, again involve real-time analytics, again fraud detection. Fraud detection is the core thing. So for the insurance, from the part of the insurance company, they have to think about fixing a premium and to whom a policy is to be given, to whom it should be rejected, say for how many years it has to be given, what are the benefits to be given, and what are the tests that are to be taken, okay, what are the documents to be submitted, all that they have to finalize. Say depending upon the customer, they will ask the customer to produce different documents, or they give different policies. Okay, they are able to give that through the research and all that work done with the past data. Okay, so they are having all the past and the earlier data for insurance, say how much money they have paid, and say for a particular policy, say it could be from LIC or it could be from Max Life. Okay, so what they will do is for this particular policy, this particular customer, or for this particular policy, this many years, for this many lakhs, okay, what is the premium amount, and how long it is being paid. Okay, so if it is taken by a teacher, so what is the track record of that person, whether the person is a defaulter or anything, and about teachers in general, say school teachers or college teachers, or if it's a student or having business. Okay, so all these data that play a role in fixing the premium. Okay, in certain cases they will fix individual premium amounts for individual persons, but in certain cases the decisions they take will affect the overall policy. For anyone with that age, that premium will be fixed, but for certain cases there will be additional premium. So here also you can identify fraudulent cases. People may fake this medical thing, the accidents and all that. So you can identify a company, CBS a customer also, we can find, we can compare many insurance providers and we can select one. And we have online facilities for them now. Then the next one is education. So here our concentration is on the students. They are the learners, and we have to identify, we are having so much of data. Okay, so if institution is running for say 20 years, and you will be having so much of student data with respect to their admission, their attendance, and their marks, details about the parents, their placement, and all these data are available. So we can use that data and you can find out how we can improve the services for the current students and for the other years. Okay, so how we can enhance teaching learning. So we'll concentrate on improving the performance of the student. And now this adaptive learning is something that is catching up. Like you identify the requirement for individual student and their learning curve and their learning capabilities, and you provide the required training to that person to excel. Okay, and then faculty assessment. Sometimes it is just the students are given some feedback forms and the students fill all the details and the faculty are assessed. But what is actually happening with this faculty assessment? Then recruitment or placement of a student plays a vital role. So what should be done for that? Then for improving the syllabus, say we are having one syllabus, and what is the output of that? Okay, like with respect to student performance, with respect to faculty satisfaction, okay, with respect to admission, and you change the curriculum, will it change the things in the positive way or in a negative way? So that can also be analyzed. Then how we can allocate the resources, and how the management has to use the resources, funding, and all that. So for everything, we can use data analysis. Then agriculture, this is actually being currently used in many cases, many areas, even in Tamil Nadu. In many cases, it is being used. So now they're going for something called as precision farming. So say if they're having 1 acre of land, say what do they want to plant there? Okay, they plant maybe some crop, in between some crop, on the border some crop, and they plant them in such a way that some produce result in a month, some produce in 2 months, some produce in 3 months. So constantly you are having returns, and when one crop work is over, say you can leave it for a few days and then you can put some other thing there. So you have a lot of planning going on there, and they're able to get a lot of profit out of it now. But of course, the rain and others are an issue, but many go for drip water irrigation. They're able to solve that also. Then this organic farming, instead of using the artificial pesticides and others, they go for organic farming. But that again, they have the data to prove that it is safe and that gives results. And some go for hydroponics, that is without soil. They go for harvesting, and about how much of food is being required, how much is being cultivated, will there be a food scarcity, like things are happening in say USA or not USA, sorry, Russia, or in Sri Lanka. Okay, so how these things have to be handled, and how we can improve the yield, and how we can identify the diseases of the crops, and how to eliminate the pests. Say without killing the pests, if you can chase them away, it will be good, but how it is possible, and forecasting the crop yield. So this, see, for every case, you can go for what has happened, how it has happened, what will happen, what should we do to make it happen. Okay, so these analytics questions you can apply to all the domains. Okay, then this is the latest one in social media, and lot of data is going on. Actually, you may think that you are getting a lot of free service. Say when something is free, we should realize that we are not the client and we are the product. Okay, so whatever we say and whatever we publish, everything goes open, and we are being used. Okay, so all our data are being used. So by this social media analytics, we refer to collecting data from social media sites, evaluating the data, and using it to make business decisions. So it is not just about how many likes we get, okay, but it is more than that. So what we do, so you spot trends related to offerings and brands. Then you understand the conversations. Say in Twitter, what you put in Facebook, what you put in blog, what you put, okay, in WhatsApp, what you type, everything goes, and they are being analyzed. Okay, so you try to identify what is the customer's feeling about a product. Okay, that is how much of say review they write. Okay, say whenever you want to buy a product, what you do, you immediately search for the review. Okay, what is being put about that particular product. If it is 4-star, then you go for it. If it is 2-star or 1-star, then you don't buy. Okay, because you have some old data and you are able to verify it. But when you have competing companies, say company A is selling some products and company B is selling some products, what they want to do is they want to know what people think about, say A wants to know what people think about A's products. Okay, along with that, A wants to know what people think about B's product. Okay, so if he finds that more than A people like B, then they'll try to find out why people like B. Okay, and then try to find out some ways of improving its own so that it can beat B. Okay, so this is what is happening with the companies when they go for finding details about their product and about another product. Okay, so this competitive companies, they really work hard to improve their sales and retain their customers. So this social media, this analysis, this helps in product development and improve the customer experience and analyzing the competitions and improving the efficiency of operation of your own company and the flow. So this about some domains. So all you can think about is in all domains, any domain you take, you think about the way or apply the various types of data analytics. So you try to find out the mean, that average itself will totally apply the techniques and you can find out what has happened. After finding what has happened, you can find out how things have happened. Then you can go for a prediction, so that you can go for regression. And if you go for data mining, you can go for classification, and you can go for clustering also, and you can go for prediction. And then you can go for finding what is that action you have to do now. Okay, so if you want some improvement, what you should do. So far we have seen about and just an idea about some of the domains, and now we'll see a few cases in which different data analytics is applied to different cases. Okay, so first one, National Stock Exchange data. So we are taking some NSE data, and okay, so the data appears like this. What is the value of one share at the opening of the day, at the closing of the day, like that. This data is taken from Kaggle. So these are some of the attributes. Okay, so you can use classification for predicting the categorical labels. Okay, so you can categorize. And next one, cricket analysis. Okay, so you have a score of players and their details. So you can put the comparisons. So like you can predict, like with this score, how much the other team can achieve. So some details. So the normal cricket scores compares. And this one is interesting. You have a survey data, and you can use the survey data, and you can so this data is given to some group of youngsters, and you get some details from them. So then you go for just analyzing the data, and maybe here you just put them into that is, we are trying to find whether there is a gender bias. Okay, so when you try to find the gender bias, you try to group the records of male and records of female, and you try to find out whether there is any bias in their liking for music. Okay, like rock music or hard rock. Guys like hard rock more than women. So likewise, you get some details. So here you try to find some relationship. Again, here we are trying to concentrate on whether there is any gender bias. Okay. Tilakraj. Okay, thank you. Okay, so likewise, you can again form a heat map for that, and outliers. Okay. Another data. So you have some chocolate bars. Again, you have some details about where it is being manufactured, etc. So using the data, you can do some analysis. So you have some details about rating, the type of bean, etc. So you can apply some data analytic techniques on the data. So depending upon the location, that is, what is that rating you have. So you could see that, say, the items from one place has more rating than item from another place. Okay, so then I have one diamond data. So this data, so it is somewhat like this. So again, you apply some data analytics technique, and you can get some correlations, regressions, and all that. Okay, so recap what data science is, some skills required. This is the core part. This is okay, like what happened, why happened, what will happen, and how to make things happen, and what your life cycle is. Identify a problem, collect the data required for that, understand the data, then form models, implement them, and then give the details to the user. Some of the references. Actually, I have something on, a little bit on data mining. Shall we see that also? Because I thought it is coming as part of it. Few slides. Okay, so I assume that you are familiar with what data mining is. It's extraction of interesting, non-trivial, implicit, previously unknown, and potentially useful standard definition. So it's about you give a certain set of input, you pre-process the data, you clean, transform, do all that, apply data mining techniques like association, correlation, classification, etc. Then you get patterns and you evaluate the patterns. So you have data pre-processing techniques as data cleaning, integration, selection, reduction, transformation, and discretization. So in classification, you have supervised learning, and so here you will have labels for the data. Say something like if it is a patient, you will have details as whether a patient has cancer or not. Okay, so in that case, that will be a label. Whether a person is having COVID or not, so that will be a label. That's for a student, pass or fail, so that will be a label. So using that label, you do some process, so that will be your classification. Clustering, it is unsupervised. And for regression, you predict the future based on past value. Associations, you try to find the relationship among the data. Okay, so for your supervised learning, you have specific input and you have the information as to how to model it. Okay, so you use the knowledge and form a model and you use it for further prediction. So you have some data, you divide the data into training and testing. Then you form a classifier model using some classification algorithms and use the model for testing. And then you use the model for when the testing results are good, the accuracy is good, then you go for finding the results of something unseen. Okay, so you go for prediction. And so this classification and the prediction, they go hand in hand. So you can go for that. And then you have different classification techniques. We can go for decision tree, rule-based classifications or if-then rules, and back propagation. You can use neural networks. Bayesian classifications, it uses Bayesian theorem and probability. The next one is clustering. So here you don't give any label as something like, say, this is grapes, this is apple, this is orange, like that. But your model, it identifies the similarity and it divides them into different groups. So you go for forming groups that will have, say within the group, the similarity should be more, and between the groups, the similarity should be less. And the last one is association, rule mining. So you try to find the relationships between different attributes of a database. So you try to find the correlation between the occurrence of certain attributes in the database. So if somebody is buying a laptop, the person may buy a laptop bag, or they may buy a wireless mouse, or they may buy an antivirus software. Okay, so you are able to say that because of the past details. So here for that association, you will say that if something happens, say if X happens, then Y also will happen. So if in a transaction, you have the occurrence of the items together, say for example, for a retail shop, say if many people are buying bread and butter together, then you will say that if somebody is buying bread, the person will buy butter also. So this you will be able to say through the transactions. Then a little bit on machine learning. So learning is something that will make you do things better a second time, that you call it as learning. Okay, so you do it the first time in one style, you learn something, and the next time you do it better. Okay, so even you don't have any human experts, in that case you go for it. Or a human expertise is something like a black box. You're not able to explain exactly how it is being done. In that case also, you can go for machine learning and rapidly changing cases, personalization and all that you can go. And you can go for the supervised learning and unsupervised learning, which you have seen in data mining. That also can be done with machine learning. Here again, you could see that the labels are used. You have a set of data. So the data can be text or documents, images or anything. Okay, from that, you select some features and you have some labels, and you can use the labels and you can apply some machine learning algorithm. That can be a say, since it is supervised learning, that can be a classification algorithm. So you form a model. Then for the new text or document, you can extract the feature and map and find out what is the label. Okay, so you use the labels for classification, and now you can classify. Say, for example, you have a data that shows that, say, if the values are like this, say this value is high and low, the person is having temperature and other factors are there, then you say that the person is having COVID. So if that information is stored, then for a new person, so you may ask a doubt, ask a question as, do you have fever? Do you have cough or cold? Okay, is anybody in your area affected by COVID, something and all, and you can conclude that the person is having a possibility of COVID, so you go for testing. So you are able to say that because you have the information of person may be having COVID as as a label, okay, and you use that label. Then the unsupervised, and here you could see that we are not using the label. So the label is not there. So, but what you do is you try to map the new one with the set of groups that are already been formed. So to which group it is nearer to, you put that as a better representation of that. Okay. So since we have some time, I thought I'll include this also. Okay, so thank you. And if you have any questions?
Any questions from the participants?
Ma'am, one question, ma'am.
Yeah, tell me, ma'am.
Ma'am, whether it is easy to convert the supervised into unsupervised learning and vice versa, ma'am?
It depends upon what kind of data you are using, ma'am. See, normally, say for unsupervised learning, will be mostly working with numbers, or we have to convert them into values. Say if you don't have any label-like information there in the data, it will be difficult to convert unsupervised data into a supervised one. Say, for example, supposing you have the student details. I'm having the student marks and all the other details. But supposing I don't have any information as whether student will be pass or fail. Okay. I don't have that information. Okay.
Okay.
So in that case, I can't go for converting this student marks alone into a supervised case. But I can form groups. I can create labels. Say I can put the students into groups like say marks less than 40. I could see that some people are having marks less than 40. I can form one group. There are people whose marks are say between 41 and 60. So I form some groups. So based on the data, I can form groups. And when I form the groups, I can attach this group information as a label. So I can say that group 1 mark less than 40, group 2 41 to 60, say group 3 61 to 75, group 4 I can say 76 to 100. So like that I can put them into different groups. Now I can use this for supervised, claiming that these are labels. But without that, it will be difficult to process because each value can be taken as a label. You can take the mark, say 51 as one label, 52 as one label, 72 as another label. So that will be difficult. So from unsupervised, you can cluster, you can form labels, and then you can go for supervised learning. You can go for classification using that. But it is easier the other way. Say without those data, you can directly go for this unsupervised data. You can use for unsupervised learning. That is, you can cluster. But the details may be broadly thing, no? Like, say it will be better to have student marks as 40, 41, 42 instead of pass, second class, first class distinction. In that case, I will be having only 4 groups. I can say that I'm classifying, but it won't be very good because say one person's mark could be 100, another person's mark could be 75, but they could be in the same group. But there is a big difference between those two, 25 marks difference, but they are in the same group. So if we go for clustering with marks, they probably would end up in different groups. I hope I have answered your question.
Okay, ma'am. Ma'am, one more doubt, ma'am. Ma'am, if I have similar groups of clusters, ma'am, in one cluster I am having some noise, another cluster I am not having any noise. Whether it is efficient to merge all the clusters to estimate the prediction value, ma'am?
If you have identified some noise, then it will be better to remove it, right? Denoise it and then work. That will be better. Okay. When you are combining, if they are at the same level, it will be better. Otherwise, it will reduce the efficiency. It won't be of the same level. Huh? So if you are very sure that it has noise, that noise has to be removed.
Yeah, we are clustering to form homogeneous groups from heterogeneous data. Then there's no point in joining again all the clusters and find the predictive result. Any other questions?
I am having one question, madam. Am I audible?
Yes, yes.
Yes, sir.
Myself, Dr. Pankaj Kumar Singh from IIT BHU. Madam, your presentation was very nice. One thing I want to say that regarding the data analytics, it is most probably centralized to the patient. Do you agree with that?
Centralized to the patient.
Yes.
It's not very clear. I'm not able to understand.
It is centralized to the patient? No, the question is not clear, sir.
Actually, that is concerned to the hospital and other medical facility that is mostly concerned with the patients. So it is most of its study is concerned with the hospitals and the patient-related studies.
Okay.
Do you agree with that?
Yes, because say patient, say something like in the school or college, we always talk about the student, right? It's student centric. So likewise, in the hospital setup, it is patient centric. So a lot of work is done on that. You are right.
Another thing that regarding the data of so many data are collected, whether it will be, if it can be misused regarding the privacy of the specific person. Do you agree with that?
It depends upon the cases, sir, because see, I have done some work, but I get de-identified data. That is, the patient details are removed and we get only that data. We don't know to whom the data belongs to. So there are a lot of agreements are to be made with the hospitals. They don't give the patient details.
Yeah,
So
patient's personal details will be hidden. Only the medical data features, the data of features will be given as a data set.
Okay. Thank you.
And getting real-time data set is itself is a big work actually. It's not that easy to get a real medical data set. So we usually work on the existing universal data set, and then we test it with the real-time data set.
But in near future, madam, I think it will be dangerous for the privacy of any person.
That's what. See, no data set will have the personal details of the patient. So it will just have the record numbers. That's it.
Okay.
No way there's a privacy will be conquered.
Okay. Thank you.
Any other questions, participants? So if there's no question, then ma'am, thank you so much for your time and for a very informative session with lots of applications on data. Actually, you had given an insight on various applications, and the new researchers would have got the ideas on where all it is applied and the new domains, and in domains also what are the focus areas. Thank you so much, ma'am, and a couple of more minutes for formal vote of thanks.
No duty is more urgent than that of returning thanks.
A warm good evening to one and all present here. A good tool improves the way you work. A great tool improves the way you think. I take the opportunity to propose the vote of thanks on behalf of UGC HRDC and Department of Computer Science, University of Madras. I deliver my gratitude to Professor V.P. Madheshwaran Sir, Director, UGC HRDC, University of Madras, for his support to conduct this national webinar. Thank you, sir. I also deliver my gratitude to Dr. N. Kodandaraman Sir, the Deputy Director, UGC HRDC, University of Madras, for his support and encouragement to conduct the national webinar. Thank you, sir. I would like to thank our resource persons, Dr. T. Kalachelvi Ma'am, Assistant Professor, Department of Computer Science and Applications, the Gandhigram Rural Institute, for exposing her knowledge on machine learning in data analytics. Your explanation helped us in getting insights on machine learning techniques and tools in data analytics. Thank you, ma'am. And I would like to acknowledge our gratitude to Dr. D. Mini Ma'am, Associate Professor and Head, Department of Computer Science, Madras Christian College, Chennai, for her explanation on the topic application of data analytics in various domains, and with excellent presentations, making this webinar interesting and meaningful. Your explanations really made us understand the importance of data analytics and its application in various fields. Thank you, ma'am. And also, I would like to thank our coordinator, Dr. B. Lavanya, ma'am, Associate Professor, Department of Computer Science, University of Madras, for organizing national webinar on data analytics. And also, I would like to thank Professor and Head, Dr. P. Tangavel, sir, Dr. P.L. Chitra, ma'am, Professor Dr. M. Swarnam, ma'am, and Professor Dr. S. Gopinathan, sir, for their support in conduct of this webinar. Our heartfelt thanks to our participants for their active participation. I take this opportunity to thank one and all who contributed to this webinar directly and indirectly. I would like to thank you all once again for making this event a grand success. Thank you once again. Thank you all.
Thank you, ma'am. Thank you so much.
Thank you, ma'am. Thank you for giving this opportunity. It is really wonderful. Thank you.
Gentle reminder to all the participants, kindly fill out the feedback form for both the sessions and you will receive your certificate within 2 working days.
Thank you all. Thank you, participants, for your support and continuous support, I should say. Thank you all.
Thank you, ma'am. Thank you.
Thank you, ma'am. Bye.
Bye, ma'am. Bye. You can stop the recording, actually.